Hello and welcome to this lesson where you will learn how to plot histograms in R. Histograms are some of the most common and useful plots when you want to show the distribution of continuous data. The ggplot2 package makes them very easy to plot and customize to suit your needs. So let's dive into the lesson. Here's an example of a histogram. You're probably already familiar with how they work. So we're going to focus on how to create the simple histogram, modify the aesthetics to make it look better, and then different ways of adjusting the bins. The learning objectives here specify the exact functions and arguments we're going to use to do this, so you can pause to read them now if you'd like, or we can dive straight into the lesson. Just as a reminder, you can download all the data and code needed to follow along with this lesson. I highly recommend that you use your computer to open RStudio and code along with me, as that's the best way to learn. If this is your first time coding along with us, look for the link that describes how to open the files and do this. Now that you have your RMD open on your computer, let's load the packages that we need for this lesson. As always, we will load in the tidyverse package, which is a meta package that includes ggplot2. We're going to use the here package for project relative file paths, and finally, the patchwork package, which helps us combine plots and align them next to each other. Today we're going to visualize distributions of variables from the mollydd data frame, which we've used in previous lessons. So let's load that in. Just as a recap, these data were collected as part of an observational study that collected clinical and demographic information from 150 children who were suffering from acute diarrheal diseases. Let's take a look at the first few rows of this data. You can do this with the head function. So you'll see here that there are 21 columns, and several of them are continuous variables, which is what we need for histograms. We're going to start with plotting the height cm variable, which measures the height of the children in centimeters. The ggplot function used to plot histograms is geom_histogram, which is quite easy to remember. So we're going to use our typical 3 required layers to make the most basic histogram. Do you remember what they are? We're going to start with the ggplot function and specify the data layer, which is the data frame we're going to use, called mollydd. Next, we need to give the aesthetic mappings, which is the variables that we want to plot. Since it's a histogram, we have just one variable. In previous lessons, we've looked at scatter plots and line graphs, which are bivariate plots looking at relationships between variables. But with histograms, we're looking at distributions of just one variable. So we're going to have x equals to height cm. And finally, our third required layer for a ggplot is the geom function, which, as we said, was geom_histogram. Now you run this code, and voila, here is our simple basic histogram showing us that there's a relatively normal distribution of heights, which is what we might expect, where there are not a lot of people who are very extremely tall or very short, and most people are centered around the middle. You'll notice here a warning message after we ran the previous code that says stat bin is using bins equals 30, pick a better value with bin width. This is because we haven't set a bin width manually. We're not going to do that quite yet, so you can ignore the warning message for the next few examples, and in the next section, I'll show you how to adjust bins. First, let's make this histogram a little clearer. It's hard to tell where these bins start and end and what the intervals are because it's kind of all one amorphous blob. One way we can fix that is to add colored borders around the bars. We can outline the bars with the color argument. Remember that there's also the fill argument, but fill will color the inside of a shape and color will outline a shape. I'm going to set color equal to white. And don't forget to put that in quotes because this is a character. Now when you run this, the bars are a little clearer. Let's also add fill color to these bars. I'm going to set fill equals to steel blue. This will color the inside of the bars. So this just goes to show that in ggplot, arguments that you learn for something like scatter plots or line graphs also apply to other types of plots. We can also adjust things like line width, and that'll increase or decrease the thickness of borders around the bars. We can also adjust transparency with alpha as we did before. So now it's time for you to practice creating simple histograms. This practice question asks you to use a different variable from the MollyDD data frame called age months, which tells you the age of the children in the dataset. We want you to also change the outline and fill color of the bars to sea green and reduce the opacity to 40%. So if this is your first time coding along with us, I'll give you some instructions for how to automatically check if your answer is right or wrong. What you'll want to do first is write the code to create your plot here. I won't give you the answer to this question. I'll just put in a wrong answer like ggplot data equals MollyDD, and I'm not going to give the rest of the required layers. That just gives a blank plot, which is clearly not the right answer. But let's just pretend I want to submit this answer for now. Once I think that I have the right answer, what you're going to want to do is delete this your answer here text and put in the code that you had for that plot. So I'm going to put in that code again. You can just copy and paste it instead of typing it again. And then I assign that code to an object, and so that will create a plot object that will appear in your environment. Once you have that, all you have to do is run the check function that corresponds to that question. You don't need to put any inputs in it. Just go ahead and run that, and it will tell you if your answer is right or wrong and print out an answer. So it's telling me, as I expected, that my answer is wrong and I need to try again. If you're stuck and you're not able to get this right, you can also ask for a hint using the hint function, which there's one for each question. So again, you just run that without any inputs, and then it gives you some instructions and pointers for how to do the question right. So you can pause now, go to your RMD, and work on making this histogram. Come back when you're done, and we'll move on with the lesson. Welcome back, and I hope that practice question went well. The correct answer to that question looks like this, so you can compare your plot to that and see if you got it right, in addition to using the check function. There's another step to this question. In the next one, we're going to change axis labels. Here you want to build on the code from your previous plot, so copy that over and add the appropriate function to change the X and Y axis titles to what it says in the text. Make sure you use the exact capitalization and spelling that is given on the question, or the check function will tell you that it's wrong. So pause here again, go back to your RMD, and come back when you finish the practice question. Here's the correct answer to this question, and you can see here that the age and number of children labels have replaced what was in the old plot, which was just the variable name and count. Now let's talk about how to adjust and modify bins in a histogram. Here you'll see these three plots. They're using the same data and plotting the distribution of the same variable, height cm, as we did before, but instead of using the default of 30 bins, I've varied the number and width of bins. So let's see how we can do this. Do you remember the warning message we got earlier? I'm going to recreate that here by just plotting the same code, and we get this warning that says stat bin using bins equals 30, pick a better value with bin width. This is telling us that the default value of bins is 30, and we can modify that using three different arguments, three different options. We can set the number of bins with the bins argument, we can adjust the width of the bins with the bin width argument, and we can set bin boundaries, specific bin boundaries, with the breaks argument. These are all fixed aesthetics, so they go inside geom histogram and not in the AES function. You should also note that you only want to specify one of these arguments. If you try to do more than one, then binwidth will override bins and breaks will override binwidth. So let's start by setting the number of bins with the bins argument. So you set bins equal to an integer inside histogram. So I'm going to set bins equals, let's try 5 to start. And here with few bins, they're wider. What if I increase that to 25? We have a lot more bins and each interval is therefore shorter. You can also change it up to 50 or 100, whatever value of bins that you'd like. Personally, I don't like it when there are these empty spots where there are no bars plotted. That is a sign to me that there are too many bars. So let's try reducing it to a value where we have no empty spaces. I'm going to try 20. Still have some there. Maybe 15. Once we get to 16, there's an empty bar there, so I'm going to keep it at 15. That's a nice number. And so that's pretty simple, just setting the bins equal to a number. You just want to choose a number that tells the story of your data in the best way. I think this does a good job illustrating the patterns without having too many bars where the pattern gets lost, or too few where you just have very wide bars and you can't see the small differences. Now it's time for you to practice. So you want to have this file open in your RMD and follow the instructions here. This time, instead of plotting a histogram of height, you'll be plotting frequency of respiration and changing the number of bins according to the instructions here. So pause now, go to your RMD, and come back once you're done. Hopefully by now you've done the practice question and the correct answer should look something like this. The second way we can modify bins is by setting the bin width argument. So we set that to any numeric value. It can be decimal or an integer. So here I'm going to play around with different bin widths. Let's try bin width equal to 2.5. With that, this is the number of bins that we get. It could be decent, but let's try maybe a bigger bin width so that we have less of these empty spaces. And it could be hard to find an appropriate bin width. One way to address that is to look at the range of values of your variable. So we're going to use the range function to see the highest and lowest value of height cm. So this tells us that the lowest value is 50.3 and the highest value is 103.4. So perhaps a bin width of 5 might be good because it starts at 50 and it'll go up to 105. So let's add this bin width of 5. And now you can see that they are pretty even and it ranges from 50 to 105. However, the boundaries might not exactly line up with the x-axis variables. Here it looks like 60 is in the middle of the bar, but we know that if it starts at 50, this should be 55 and 60 should be right here. We can fix this by adding an extra argument called boundary. So if we set the boundary argument, we can align the bins to the x-axis interval. We want to set boundary to the lowest value, so we're going to set it equal to 50 because that's a whole number towards the end of our histogram. And once we do that, you'll see that they line up, and so you can see that this is 50 to 55, this is 55 to 60, and so on. So that looks neater, and so you can use that boundary argument and set it to the lower end of your histogram value. So now this looks much neater, and you can tell what the intervals are. This starts from 50 to 55, 55 to 60, and so on, so it's easier to interpret the histogram. So you can set the boundary equal to the lower end range of the numeric variable that you're plotting in your histogram. Now it's time to practice using bin width and boundary. So you want to create the same histogram from the previous practice question using freq recipe and set the bin width to a value that results in 18 bins. So look at the range of this variable and figure out what the bin width needs to be to get that number of bins. Then you also want to set the boundary so it lines up with the x-axis again. So pause now, work in your RMD, and come back once you're done. The correct answer to this practice question is this plot right here. Hopefully you got that right. If not, look at the hint and try again. The next section we're going to look at is how to use the breaks argument to adjust bins. This is personally my preferred way to do it. So you set breaks equal to a numeric vector inside geom_histogram to specify exactly where you want to start and stop and what the interval is. We're going to use the sequence function similarly to what we did when we set scale breaks using scale x continuous and scale y continuous. So here I'm going to add breaks equals, have a sequence, and I'm going to start with 50 and go to 105, and I want my intervals to be 5 centimeters long. And now this is the plot that we get. We didn't have to set boundary this time because the breaks lined up nicely with the ranges of values in the data itself. So now it's time to practice using the breaks argument, again with the frequency of respiration histogram. The first step asks you to use the breaks argument to set certain boundaries, and the second step asks you to add a scales layer. We haven't talked about scales layer in this lesson, but we have in previous lessons in the line graphs lesson, where we learned how to use scale x continuous and scale y continuous to assign axis ticks in the desired places on the x-axis. So think back to what you learned there or refer back to that lesson if you need help with that problem. So pause now and practice in your RMD. Come back when you're done. If you've made it this far. Hopefully now you feel confident making histograms in R. Finally, let's close by reviewing the learning outcomes that we set at the beginning of this lesson. Today we learned how to plot a histogram, customize different aesthetics in it, like color and fill and opacity. We've been able to adjust the number and width of bins, as well as align them properly with the axis to make them look nice. And finally, we're able to specify a numeric vector which tells the histogram exactly where to break and position our bins. If you have any questions about this lesson, please feel free to mention them in the comments or message me on the Graph Courses portal. I hope that you will be back for later lessons as we'll explore different types of plots with ggplot2. That's all for now, and goodbye.